Hello student. See, in last 3 lecture we have discussed different variation of RS flip-flop, set reset flip-flop. In the first lecture we have discussed clock RS basic circuit. This circuit is asynchronous, independent of clock pulse. Then in next version we have discussed clock RS flip-flop. Here we have applied clock pulse. It is a series of square wave. This circuit is better than simple RS because this is a synchronous circuit. But this circuit has one disadvantage, that T on time is very high. So as T on time is high, there are chances that unwanted signals like noise enter in the circuit, and that is actually this is a very serious problem. So to eliminate this problem, we have designed Htriggered RS flip-flop. So Htriggered RS flip-flop is the best version in this family. But still one disadvantage is left in this circuit, and that is when S is 1, R is 1, circuit enter into forbidden state because Q and Q bar are at the same level. So this is against the basic rules of flip-flop, that Q and Q bar should be complement of each other. So to eliminate this problem, forbidden state problem, we have designed DFlip Flop, data flip-flop. So in today's lecture, we are going to discuss both the variation of DFlip Flop. DFlip Flop is used in the memory section of your computer. Okay, so it is used in the present world. This DFlip Flop is used in this present world. So first we discuss clock DFlip Flop. To design this clock DFlip Flop, we have to make only one modification in basics clock RS circuit. So basically the circuit remains same. SR flip-flop, S, R, Q, Q bar, here 2 AND gates. This part is your clock signal. Right? So up to this circuit is same. SR, AND gate, clock pulse. Now in previous, here there is S input, here there is R input. Now one change. D is here. And here I have introduced a NOT gate. So you can say that this is D and this is D bar. So in place of two inputs, S and R, this circuit has only single input. This circuit has only single input, that is data input. Okay. So your truth table, clock, D, Q and action. Let's give the number 1 and 2. Suppose clock pulse is 0, D is 0, what happened? So if this input is 0, clock is 0, these two are 0, so whatever D is either 0 or 1. Output of both the AND gate is 0. That is clear? Because in AND gate, when any input is 0, output is 0. So S is 0, R is 0. S is 0, R is 0. That is no change condition. Flip flop retain in the last state. And even if D is 1, the result remains same, because one input clock pulse is absent. So here in place of 0, I say that this is don't care. D input doesn't have any impact. Okay. Now, second case. Suppose your clock pulse is 1, means clock pulse is high. So this part is available. So this AND gate works during this positive transition. Okay. Now, if D input is 0, D input is 0. So this part is 0, 1, this is 1 because clock pulse is high, and D is 0, this is a NOT gate. NOT gate is a function of inversion. So if D is 0, this is 1. So 1, 1 means it is 1, 0, 1 means 0. Again, clock is available, clock pulse is 1. So these two inputs are high. D is 0. So this part is 1 because this is a NOT gate. So output of AND gate 1 is 0 because inputs are 0, 1. And output of AND gate number 2, both the inputs are high, so it is 1. So we can say that S is 0, R is 1, S is 0, Q is 0. And we can say that flip flop is reset. Clear? Clock is available, D is 0, so this one is 0, D bar is 1, so this is 1, 0, 1, so it is flip flop is in reset state. Okay. Next, suppose D input is high, clock is available, clock is high. So one input is high, D is 1, so D bar, this one is 0. So as far as AND gate number 1 is concerned, both the inputs are high. So its output is also high. Here one input is 0, another is 1, so 0, 1, so this one is 0. So 1 and 0. S is 1, R is 0, flip flop is set. flip-flop is set. So, here there is a single input, data input D. So, only two cases, either your flip-flop is set or flip-flop is reset. So, the problem of forbidden, that Q and Q bar complement to each other, is automatically eliminated. And that is why this one is very, very popular flip-flop. There is no forbidden state, so there is no possibility that your system is hanged. Circuit always either in reset mode or in set mode. And even if clock is not available, flip-flop is in previous state. And previous state means Q is either 0 or 1. So, in any circumstances, flip-flop remains in valid condition. So, the biggest disadvantage of RS flip-flop, that forbidden state is very easily eliminated. So, in your memory section, permanent memory section of your computer, that is read-only memory, this flip-flop is used. D is 0, Q is 0, D is 1, Q is 1. So, in this format, data is stored. Symbolically, it is represented in this way. This is your clock input or enable, whatever you want to say, series of square wave. This is Q and this is Q bar. This is your data flip-flop. Whenever you see this symbol, remember Q follow the action of D. Q follow the action of D. D is 0, Q is 0, D is 1, Q is 1. There is no other. The only thing is, if the clock pulse is absent. If the clock pulse is absent, flip-flop is in previous state. That's it. Okay. So, this is clock D flip-flop. Very easily we have eliminated all the problems. But still this circuit has one problem, that what we have discussed in clock RS, that T on time is very high. This is a square wave. So, let's say, again I am going to explain what is the problem. This is your period, capital T, periodic time, time to complete one oscillation. Now, this part is known as T on time. This part is T off time. Here, T on time is 50% of your total period. This is very high time. Ideally, I have told you that only 1 to 2% should be your T on time of the entire T. Okay, suppose capital T is of 100 nanosecond, then ideally T on is 1 or 2 nanosecond. It is off. Now here it is 50 nanosecond. So what happened? Again, glitch occurs. Unwanted pulse arrives. So in last example I have told you, okay, if S is 0, R is 1 and unwanted pulse arise and S become 1, circuit enter into the forbidden state. Here that is not the case. For it is not going to happen that flip-flop enter into the forbidden state. But what happen? Suppose your D is 1. So ideally Q should be 1. An unwanted pulse arise and D becomes 0. Immediately Q is become 0. So you think that I have applied D as a 1, but output is 0. How it is? So it is not the fault of hardware. It is because of noise signal this problem arise, unwanted pulse, and this unwanted pulse arise due to high T on time. So to eliminate this problem, we have designed age-triggered DFlip flop. So second variation of DFlip flop is age-triggered DFlip flop. So one change in this basic circuit, that RC differentiator is introduced here. This part of the circuit exactly remains same, but here clock or enable signal, positive triggered, PT means positive triggered. So now you have a spike. You have a spike. Differentiator circuit, clock, that means you are applying a square wave. And this is a spike. So it convert square wave into positive and negative spike. Positive spike, this circuit works for that one, so that's why it is positive triggered. PT is applied here. Okay. Now working. Suppose clock pulse is 0. Clock pulse is 0. Either D is available or absent, doesn't have any impact on the output of AND gate, because one input is already 0. So this one is 0, this one is 0. So it retained the last state. Okay, it retained the last state. Now when the clock pulse arrives, you have two possibilities: positive clock as well as negative. This is positive, this part is negative. So first consider that positive age triggered pulse arrives. So we are using this symbol. So this input is high, D is 0. So this input is 0, this input is 1, because it's a function of NOT gate. So 0, 1 means 0, 1, 1 means 1, S is 0, R is 1, S is 0, Q is 0, Q is 0 means reset state. Flip-flop is in reset state. That's it. Second possibility, D is 1. So this part is 0. D is 1. So both the inputs of gate number 1 is high, while gate number 2 is low. So Q is 1. You can say that flip-flop is set. Still one more case is available. Think about it. Clock is 0 as well as positive triggered. Still one more case is available. Yes. Suppose negative 8 triggered clock pulse arrives. Then in H triggered RS flip flop, we have also discussed this case. Negative 8 triggered is equivalent to 0. It is absent. In absence of clock pulse, whatever D is, either it may be 0 or it is 1. 0 or it is 1. Flip flop is in last state. Flip flop retain the last condition. So this version is better compared to the previous one, because here there is no possibility of unwanted pulse, that is noise signal. So very easily we have eliminate both the problems. Forbidden case, that is Q and Q bar is same, as well as circuit becomes synchronous and there is no possibility of error signal to enter into the circuit. So this is the second version of DFlip flop, age triggered DFlip flop. Okay, symbol is same. So here you can say that if you want to make modification in this one, then also here in this symbol you can say that PT square wave is applied here, clock, and you obtain the spike. So it's clock pulse, that's it. Okay, or even directly you can say apply this one as a clock and you can represent. So symbolically it shows that when D flip flop, it's a single input circuit, D is 0, Q is 0, D is 1, Q is 1. So we have discussed 5 flip flops. Our journey starts with RS flip flop, 3 versions of RS flip flop, and 2 of D flip flop. So almost we are at the state that this is considered as the best circuit, H triggered D flip flop. Simple RS, 2 disadvantage. First, circuit is asynchronous and second disadvantage is forbidden. So first disadvantage is eliminated in clock RS. Definitely that is a synchronous circuit, but it has the problem of forbidden, as well as one another problem added, that chances of noise signal is introduced. So to eliminate this noise signal, we have developed H triggered RS flip flop. So that problem is eliminated, but forbidden state is there. So to eliminate forbidden state, we have designed a flip flop that has single input. Actually there are 2 inputs, but here NOT gate is introduced here. So D is always opposite to D bar. So never, your inputs are never equal state. See, in RS flip flop what happens, when S is 1 and R is 1, forbidden state occurs. Means when the inputs are at same level. Here never input become in the same level, because D and D bar always complement to each other. So your inputs are not in the same level, so there is no possibility of forbidden state. And in simple D flip flop, again the same problem of noise signal. So we have introduced H triggered D flip flop. So that is the best circuit, H triggered D flip flop. Okay. Now I think this is the best one, but in certain case we required some modification in this circuit. As per the demand of industry, we have to modify this circuit. So in next lecture, we are going to discuss this modification in detail, and that is very useful for you. Okay, thank you.